joins now, they'll just have to follow along. Let me quickly just turn my video on so that you can see me. There we go. Okay then, let's get started. So, hi, I'm George. I'm founder and lead instructor here at Flatpak Coders. Flatpak Coders is a new online sort of bootcamp. We train people in the most in-demand skills that there is at the moment, and that is software engineering. But a little bit about me. I'm a full stack engineer. I've been a cloud engineer, I've been a site reliability engineer, web development, control systems, programmer, all that kind of thing. So I've had lots of fingers in kind of lots of pies, if you like, in kind of the tech world. I've coded in, and I've written software in JavaScript, Bash, done a bit of HTML, CSS for front end. I've used Golang, PHP, C, C#, loads of different languages, but my favorite language by far has to be Python, which is the reason that we're all here. Outside of work, I'm at the moment not doing much training, but I'm normally training either cycling, swimming, or running, and I've just recently actually completed an Ironman triathlon in Italy, which was good fun. But now I can kind of get back and focus on tech, on coding, which is quite nice. So a little bit about what we do at Flatpak Coders. So as I said before, we provide life-changing career focus courses in in-demand skills. So what you're interested in, software engineering, specifically Python, this is part of our bootcamp course, both in the immersive 12-week and also in the long-term 36-week program that we do. All of our long courses, I should really update this actually, all of our long courses, like I've just described to you, the 12-week and 36-week, come with full day one-to-one career coaching. So that basically means from day one of starting the course to day one of you starting your new job, we're there supporting you, whether that's CV help, interview prep, mock interviews, personal brand, getting your LinkedIn all sorted. We're kind of behind you every step of the way. And one of the great things about Flatpak, I think anyway, maybe I'm biased, is that we strictly limit the sizes of our cohorts to 12, with 3 extra spaces for when people defer. So you'll never be on a program with more than 15 people. And unlike some of the other boot camps that I've taught for other providers, that we'll put 30, 50, 100 people on courses, and you really don't get the instructor kind of with you and teaching you as a person. It's more just they're delivering content. So that's what we're kind of about, is we're trying to be the best educator rather than just the biggest grower or the biggest provider of education. Okay, so that's the salesy bit out of the way. Let's get on with the reason you're here, is learning some Python. So what are we going to look at this evening? So firstly, we'll have a look at what is Python. And then we'll have a look at what is coding in general. Where does Python kind of fit within that? We'll look at some Python syntax. We'll have a quick 5-minute break just to get coffee, water, over a comfort break, whatever we need. And then we'll actually build something useful together. You will actually have the chance, assuming you've not done any coding previously, we'll make some software together. We'll make something actually useful. The thing that I've got in my head at the moment is that we'll make a little quiz app, and it is part of this. But we'll see how that goes. You will have the opportunity to sign up for an online IDE, an online space where we can write some Python code, but we'll get to that later down the line. We'll have a look at some next steps if you want to continue learning, and there will be time at the end for questions and answers. So if you've got questions that are really burning that you just want to get out there, feel free just to put them in chat. I have got the chat box open next to me. So if you just want to ask something about what we're doing straight away, I will try and get to those as we go. But if it's a more general question, feel free to leave it till the end and we can talk about whatever it is that you want to talk about. Right. What is Python? Okay, so there's going to be quite a bit of jargon here, but that's okay. I'll try and explain it as best as I can as we go along. So Python is a really popular high-level programming language that was first released in 1991, which means it's actually older than me. Just because it's old doesn't mean that it's obsolete. It's always being updated, and we'll get to that in the third point here. But what do we mean by high level? Well, computers can only understand zeros and ones. That's something that you may already know. They can only understand binary data. That's not very easy to read, and it's not very easy for us humans to write either. So what engineers do, and what engineers have done, is create kind of languages that are easier for humans to write and read, that make the zeros and ones for us. They kind of take this data that we tell, this kind of these sentences, this syntax that we give it, and then it translates that into the zeros and ones for us so that the computer can actually execute the code. Low-level languages are stuff like assembly. They're very difficult to read. And lower-level languages, things like C and C++. Even though they're technically high-level languages, there's a bit of kind of opinion that comes into it, you know, what you regard as low-level, high-level, etc. The thing is that Python's a very high-level language because it actually takes quite a lot of computing power to get it to run, to make those zeros and ones. But we'll have a bit of a talk about that in a bit when we actually start writing the code. So Python, again, is designed to be a really easy to learn language. It's easy to learn, it's easy to read. It's got clean and concise syntax. There's a bit like English. So when we start looking at stuff, at the actual programming, hopefully you'll get to see, oh, this is kind of how I might say that in just as a sentence. In fact, sometimes I'll be writing a program and we write something called pseudocode. And it's basically code that doesn't work, but it just kind of puts out everything that we think the software can do. And then I realized that I've actually just written Python because it's very similar to English. So like I said before, whilst it's an old language, it's constantly being developed. And that's because it's a completely open source language. Anyone can contribute to its development, even you guys and me. You know, we could go to the Python GitHub page. In fact, I will just put the source code in Slack. Here, if I copy that. Sorry, not in Slack. I will put it in the chat box here. And there you go. You can go ahead and look at the actual source code that makes Python work. It was invented by the guy that's on the right here, Guido van Rossum. He invented it in the Netherlands. I think he is Dutch. And he's what the community have called Python's benevolent dictator for life. And it's basically that anyone can contribute to Python if they think it's a good idea, but his word is law. If he says this is a really bad idea, it's probably a bad idea. He made it, he gets to say that. So why Python? What's so kind of great about it? And why is it important, I think anyway, to learn as a first language or to learn as a programming language at all? Well, that's because it's really popular. And popular doesn't necessarily mean like the popular kid in school. What that means is that loads of people use it, loads of people want it, and that means there are jobs in it. And this is actually taken from the Stack Overflow developer survey that happened this year. And you'll notice something. So on the Flatpak course, we teach 4 out of the 5 things that are listed on here. So we teach JavaScript, we teach HTML, CSS, Python, just like you're here now, and SQL, which is or SQL, which is a database language. So we teach, amongst other languages and other technologies, we actually teach the most popular languages because they're just the ones most in demand. And as we can see here from the developer survey. The great thing about Python is being a first language is that it's kind of like a gateway to other languages. So when asked on the Stack Overflow developer survey, they asked Python developers, what languages do you want to work with? And they did this for all of the languages that you see here. But what you see is that people that learn Python go on then to learn other languages for other things as well. So, for example, JavaScript being slightly more popular, you see it's a slightly bigger band around the edge there. Python developers are learning JavaScript as well, and vice versa, as well as with other languages as well, which I think makes it a fantastic first language because it's a gateway to the whole world of software development. So let's have a little talk about code. There's something that I want you guys to do, because we're going to have a little bit of a talk about what software engineering is and coding and software development is. So if you wouldn't mind, you open the chat box, set it to everybody so that everyone can see what you write. And just put what comes to mind when you see the following words. What is it? And I've got the chat box open here so that I can see what you write. Building products? Yeah, absolutely. Yeah, I mean, that's probably our number one thing, you know, whether you work for Google or you work for someone else. Yeah, building products. Anyone else want to have a think as to what comes to mind when you, yeah, writing scripts? Absolutely, yeah, scripting. Yeah, that's, I mean, some people say that Python is a scripting language. So, you know, that's writing kind of instructions to a computer. Yeah, debugging. Yeah, absolutely. What I spend probably 90% of the time doing. We'll actually come on to that in a moment. Yeah, excellent. These are all things that are part of coding, software engineering, and software development. They're all basically the same thing. But for me, what it comes down to is, if I just go into the chat box, there we go, is telling a computer in excruciating detail to do something. Now, that could be go and get some data from a database. That could be put together some images on a website. It could be anything. But it's telling a computer step by step in tiny, tiny detail to do something. So that's all very well and good, but what does that actually entail? What does that look like as people, you know, as developers? Well, first of all, it's problem solving. You need to define the problem that you're trying to solve, decide on the approach to take, which algorithms you're going to use, and an algorithm is just a set of instructions. Understand what inputs you might receive, and understand the outputs that you expect. So, for example, when we talk about define the problem you're solving, if you're going to a birthday party, one of the problems might be that you need to take a birthday cake. Well, there's many ways that you can solve that problem. You could go to the shop and buy one. You could phone up a cake baking company and say, I'd like a cake, please. You know, you could go to the shop and buy the ingredients for a cake and bake it yourself. You're there to solve this problem. Now, in a more coding sense, what that problem could be is something like we need to send emails to a specific sector of our customers based on this data. Well, there's many approaches to solving that as well. deciding on correct algorithms, they're just sets of instructions. People talk about, the Facebook algorithm or the Instagram algorithm. Well, algorithms are just instructions. I'm sure we've all probably followed an algorithm while we're taking directions to a place, maybe from Google Maps or something like that. And understanding the inputs that you might receive. Is a user going to type a name into a box? Are they going to click on a button? And then what happens when those things happen? What kind of happens when a user clicks on something or when a piece of data is received by our software? Once we've done all that, we can then start actually writing some code. So we want to write the program to solve the problem that we've just defined. And what this entails is just using text editors to create the files that the computer that will then read to make the zeros and ones and do the thing that we've asked it for. And we do this by typing out the correct syntax for the language's either compiler, whether it compiles it into zeros and one, or whether it interprets it into zeros and ones. Don't worry too much about what those two things mean. We'll have a little look at that shortly. Somebody said debugging in the chat. Yeah, absolutely. So bugs can be kind of one of two things, really. They can either be just typos in the code. You've just accidentally written the wrong thing. But they can also be kind of if you've done incorrect maths, or say you've added one to something that you shouldn't have done. If you're trying to work out somebody's age based on the year they were born, maybe you're saying they're a year older or younger than they are because they haven't had their birthday yet in that year. Could be any amount of things, but that is where testing comes in. So you need to always be using your software to understand where things don't quite work. Does your software just completely crash and stop working? Or does it work, but just not quite in the way that you'd expect? Well, that's where you go back to the bug fixing. So yeah, it's basically making sure that when X happens, the correct Y happens afterwards. And this is, I think, why developers get paid so much, is because there's so many things that can go wrong. And we're kind of expected to catch them before they go wrong. That's not to say that it doesn't go wrong sometimes, but yeah, that's kind of what we're employed to do by the companies that we work for. Okay, so that's kind of software engineering and Python. Let's talk code. Let's actually have a look at what kind of is in Python, what Python allows us to do, and how we do those things. Now, don't get too worried about memorizing all of this. The best way to get comfortable with any language or any new subject is to kind of do it, is to actually use it. But what I do want to do is just give you a quick introduction to all of the kind of the components and give you so that you have a little bit of familiarity, that when I say, oh, we're going to make a variable here, you at least have a grounding of what a variable is. So don't worry if this sounds a little kind of like double Dutch to you, but it'll all make sense when we actually start writing some code. So one thing that is available to us in Python and in every programming language, for that matter, is variables. And these are kind of like buckets of data. You can think of these as just little buckets that you can put some data into. Now, we can put strings, we can put numbers, we can put structured data, such as lists of things, or dictionaries, which is like key and value. You know, like a dictionary has a word and then a definition, key and a value. And we can save these in memory on our computer under variables. So in Python, how do we make a variable? Well, the first thing that we need to do is just think of a name for our variable. So you see here, I've put my underscore variable, and then we add an equal sign. And then after that equal sign, we put the data that we want to save in that variable. So here you can see that we've got the string some data. Notice as well that I'm using my underscore variable. You don't need to do that, but in Python, we use something called snake case. So snakes, Python, kind of makes sense, right? You split up different words using that underscore character, and that's just convention. That's kind of been accepted as the way to do it. So what other things can we save in variables? We're using strings here. So the types of data, a string. So you can see that in our first example, we're using single quotes to tell Python that it's a string of characters. In the second example, we can see that I'm using double quotes to say to Python that this is a string of characters. Either one works, but we can have a little bit of a look at why sometimes you need to be careful with which one you use. We can have integers in our variables. So in this instance, I've got the integer 22, and these are whole numbers. We can even have floating point numbers or decimal numbers. Now, we don't really need to do anything different here. We just need to use the point, the full stop character to tell Python that this is no longer an integer, it is a float data type. Like I said before, we can have structured data, we can have lists of things. So what we do in Python is we encapsulate listed stuff in square brackets, and we split those up using the comma symbol. Now here you can see that we've got a list of strings, but we could have a list of integers, we can have a list of floats. We can even mix up that data if you wanted. We could have a string, then a float, then an integer, then a dictionary, then even another list inside our list as well. And the final one that I want you to kind of have a bit of a familiarity with is dictionaries, or dicts. Now I have to be very careful how I say that, especially because this is being recorded. But these are key and value kind of structured data. So you see here that I'm saying key 1 is a string of value 1. Key 2 has a value of 55. And key 3 has a value of a list of strings. So we can kind of nest that data down. Don't worry too much if that doesn't make a lot of sense right now. We'll have a look at how we access these bits of data and how we can use them in the app that we build later. So another thing that we can do in any programming language, but this example will be in Python, is making decisions or conditional statements. Now, for this, I need you to understand a concept called Boolean logic. Don't worry, it's not as scary as it sounds. It's more just that something can either be true or it can be false. So, for example, I am wearing a polo shirt is true, that that statement has a Boolean value of true. But if I said I am currently dancing in Hawaii, that statement is false. That is a false statement. So it's Boolean, it's either true or it's false. And in Python, we can have Boolean values, true or false, and we start those with an uppercase T or S. Other languages, they can be lowercase, but in Python, they have to be uppercase. So how do we make decisions based on those things, based on that value? So we use something called an if statement. So we say if, then the value, so if something is true, we add a colon, and below that we say do something. So in this instance, we're saying print out my bool is true. And that will kind of print to the console, to our output of our program, which we'll see later. We can also do, if something is true, do something. However, if it's not, do something else. So if my bool is true, print my bool is true. Otherwise, else, print my bool is false. We'll have a look at this in the live coding, but it's just important to know that we can say if something, do something. Else, do something else. So if that wasn't complicated enough, we can also make many decisions based on, we can say, if something is true, do something. Else, if something else is true, do something else. And else, if something else is true, do something else. You know, and we can stack these up and up and up as many times as we need. So in this example, you see that we've got num1 and num2. Num1 is the number 2, and num2 is the number 5, just to make it a little confusing. So what we're saying here is, if num1 is greater than, and you see that that little angle bracket there, that's the greater than symbol. If num1 is greater than num2, we'll print num1 is greater. Else, if num1 is less than num2, because the opposite side of the of that angle bracket, we're going to print num2 is greater instead. And then else, if they are equal, and you see in Python, before we were assigning variables using the single equals. Well, what we can do is we can say compare these two things, and if they are equal to each other, we use the double equals sign. And in this instance, we're saying print the numbers are equal. Again, don't worry if none of that makes sense. It's just something to bear in mind that we can make many decisions based on whether things are equal or greater than or equal to even. So in this instance, we would actually get the output of num2 is greater because num1 is less than num2. Excellent. So one thing that computers are brilliant for is doing the same thing many times. I don't know about you guys, maybe I've got a bit of ADHD or something, but when I have to do a repetitive task, I get very bored very quickly. So one of the reasons that I became a software engineer is because I can automate those repetitive tasks. Anything that I have to do many times, I can get a computer to do. Well, in Python, we have kind of two types of loops. There are more, but these are the two kind of main ones that we see used. And we have something called a while loop that I'll show you to begin with. And what this basically says is, while something is true, while a conditional is true, keep doing the stuff in that code block. Keep going, keep doing it until it is no longer true. Now, in this instance, we're not checking whether if that while is ever going to stop. Running is always true, so this while loop will never stop running. So in this instance, we would get a computer that completely just keeps running that, keeps saying print's running, print running, print running, running, and then it will just fill up all of our memory, and then we'll end up with an error and our program will crash. So you do need to make sure that if you're using a while loop, you do stop it. You do something that changes that running variable to false. A slightly safer one, but isn't used in every instance. Sometimes it's the only one that you can that's kind of is suitable for what you're trying to do, is a for loop. Now the for loop will iterate over something. It will do something an amount of times, and it will only do it that many times. So in this example, will have for the number in a range of 10. So what range does, it will make something, it will make basically a list that's 10 numbers long. What we're going to do is we're going to print each one of those numbers. So what do we think is going to happen here? Are we going to get numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Let's see what we're going to get. Oh, okay, so we got 0 to 9. Okay, that's because range makes, it's kind of like a list of numbers that starts from 0 and however many elements long that we tell it. So there are 10 numbers in here, but they just start at 0. Okay. Don't worry if that made no sense to people. What I want you to take away from this is that there's ways that we can make our computer do things in a repeating way. We can either make it do that indefinitely, or we can make it do that a number of times. Okay then, so one last thing that I want to go over. Every programming language, or nearly every programming language that's kind of used commercially anyway, has this idea of functions. And that's where we can write code once, and we can use it many, many times. Just like I said, I find it really tedious when I have to write the same thing again and again. So I like to be able to write a function that does one thing and then just use it later on in my code whenever I need to. So in this first example that's here on the left, you'll see that we write functions using the def keyword, DEF. And this is, we are defining our function. And we're defining here the function say hello. See that underscore again? We're using that same naming convention. We have to put parentheses if you're using American English, or brackets if you're using British English, after the function name, then colon, and then we indent our code block, and we say, hey, do something. So you do need to then call upon that function later on in the program. So you see here, we're calling it by saying say hello, say underscore hello, and then we're instantiating, which is just a technical word of calling upon that function with that set of brackets or those parentheses. So the output that we'd get from this program should be the word hello and then the word hello, right? Yep, and that's what we get. Fantastic. One thing that is quite cool about functions is we can pass data into the function so that we can have our function kind of do different things depending on the data that we give it. Now, these are called, so you see here we've got def, just like in the first example, name for our function, and then in those brackets, in those parentheses, we actually have a parameter. And this is basically like a little variable that we can use in that function. So what we're going to say is, in this say hello, the one on the right anyway, we're going to say print the word hello, and then whatever we've passed to that name parameter. I'm going to use a different word for this when I talk about the next few lines of code. So what we do is, when we call upon that function, we pass it an argument. So that argument goes into that parameter, the name parameter, and then we can do something with that. So what we should get here is hello, Samantha, and then hello, Robert. Let's see if we get that. Excellent. That's exactly what we get. So don't worry again if that didn't make too much sense. What I want you to take away from this one is that we can write code once in a function, and we can call upon that code later on in our program. And that we can also pass data into our functions to do different things every time they are called upon. Okay, that was a lot of me talking and a lot of PowerPoint and that kind of thing. So let's go on a very quick 5-minute break. So gives you an opportunity to get more water. I will probably be topping up my coffee to give me some more energy for the second part of this. But when we come back, we'll start on the live coding session so that we can actually write some functional Python code together, which should be quite fun. All right, I'm going to turn my camera and my microphone off, and I will see you back here in 5 minutes. Okay, then here we are back. Hopefully, everyone was able to get everything they needed. I'm very stressed making another espresso. Hope that everyone got everything they needed. Okay, so this is hopefully where the session might just ramp up a little bit. What we're going to do is we're going to have a look at doing some actual live coding. Now, you were sent a welcome pack that had some links in it, but don't worry if you have not, you've not seen that. If you would like to follow along and code along with me, then please go ahead and sign up for a Replit account. Now, Replit is just kind of an online space where we can write Python code. I mean, we can actually write lots of different languages, but we're going to be writing Python. Feel free to choose any of the options when you sign up. I think you can sign up with Google, you can sign up with just email and password, excuse me. But just there's no need to pay for it. We just need the free account and the free options. So I will just give everyone a couple of minutes to go ahead and do that if they so wish. If anyone's having any problems as well, please feel free to just put them in the chat. So whilst that's happening, let's have a little chat about what we're actually going to be coding. So here's the project brief. So you work for a software development agency, and a school has approached us at the agency to create a quiz application for them. The school's IT teacher has very kindly provided the questions and answers for us as a list of Python dictionaries. Handy, at least somebody there knows a bit about coding, so they've been able to give us the data that we'll use in the application. And I don't know if anyone here has ever worked in agile kind of methodologies and agile workplaces, but we use something called user stories a lot. And this is basically, we want to know what the user, the end user, is actually trying to get out of our program, and like what they actually want to happen. So the user story for this is, as a student, I want to be able to test my knowledge of the planets and the solar system. Okay, so that tells us that we need to create an app that allows the user to type in some, or gets asked a question, and then they can type in an answer, and we need to know if that answer's right or not. Okay, yeah, that sort of makes sense. I think we can probably put that together quite easily. Right. Also in your welcome pack, you will have received right at the bottom just some code, some pre-prepared code that the IT teacher, or me, the IT teacher at the school has already put together for us. I'm just going to drop that in the chat box so that if you are following along, and it is optional to follow along, but I do suggest that you do. If you want to be a Python developer, you're going to start writing Python. So what I'm going to do is I'm just going to paste that pre-made code into the chat. Now, don't worry too much if it doesn't make sense or too much sense. We will go over it during the actual live coding session. Okay, so if you just give me a few seconds just to get prepared and get my Replit open and ready. Okay, so here is Replit. Okay, so anyone that's just signed up should have something that looks a bit like this. Yours might be a bit different. You might have light mode on. It might be different, but it should look a bit like this. You should be on replit.com. You've logged in. You've got a create REPL button just up here. Yeah, you've got a sidebar and some other stuff here about, deployments, and it's a homepage. Okay, so the thing that we are interested in here, I'm going to assume that you've all signed up because nobody's come back to me in chat. But we want to go ahead and hit this create REPL button. Now, I have created these before, so I have got Python in my favorites here. But don't worry if you don't. In the search templates here, just search PythON, and you want to make sure that you're just taking the Python or the Python beta there. Don't do any of these with Hugo or HTTP servers or anything like that. We just want a basic Python REPL. Give it a title, give it a name, something interesting. I'm going to call this School Quiz App, but you can call it whatever you like. We can keep this public. Doesn't matter. There's no sensitive data in this. There's nothing that if it gets out into the public, it's going to bring our company down or going to cause any issues. We can keep it public. And then we're just going to go ahead and hit create REPL. Now this will take a couple of minutes while it just all sets up. Now, just so you know, I have had a couple of problems with Replit, but it seems to be the best one for what I want to do, or what we want to do here. So if there's a few problems, it gives us an opportunity to talk about what might be going wrong, etc., etc. So let's have a quick look around the REPL. So here we've got some files. We've got our main Python file right here. This is where we're going to write all of our code. Don't worry about these. These are just what Replit uses kind of under the hood, if you're American, or under the bonnet, if you're British, to get our code to work in their environment. So here we have where we can write our code, and here we have our console where we can output our code. So where do we start? Unfortunately, we've got kind of that blank page syndrome. Well, we've just got a blank page and we need to make it do something. So first thing that I'm going to do is I'm going to get our questions and answers into our application. So what I'll do is we'll save this in a variable in a moment, but let's just write out what we need to do. So I'm going to write a comment to say a list of questions and answers. So the way that we do that in Python is we use the hash symbol. Here you go. Let me just zoom in there a couple of times so that everyone can see what's happening. In Python, we use the hash symbol. So I'm on a Mac, so I used option 3. I think use Shift and then it's over to the right-hand side of your keyboard if you're on Windows or Linux. But we use the hash to say, hey, Python, ignore this line of code. So what I'm going to say here is a list of all questions and answers. Okay, unfortunately I've got AI autocomplete on. I'm just going to turn that off because what that's doing is it's going off to ChatGPT and it's looking at our comment and saying, oh, I can probably write that code for you. I'm not interested in that. We're learning here at the moment. We don't want ChatGPT helping us at all. So we're going to have a list of all questions and answers. And we're going to save this in a variable. So how do we do that again? Everyone shout it at your screens. I can't hear you, but I'm going to assume that you got it right. Okay, so we make a name for our variable. So we're going to say, we'll call this quiz underscore questions. And then what do we need? We need an equal sign. And then what I'm going to do, I could type out all of our questions and answers, but I'm going to be lazy and I am going to just copy it from the chat. Command C or Control C on Windows. And paste it in here, Command V or Control V on Windows. Was that lazy? Absolutely it was, but it's quick. So let's have a little talk about what we've got here. We've kind of got two data types here. Well, three data types here, actually. We've got a list, and we know that it's a list because it's encapsulated by these square brackets here. Inside that list, we have got dictionaries or dicts. You'll sometimes see these in other programming languages called objects, but in Python, we call them dictionaries. Now, each of these dictionaries has a key of question and a key of answer. And these answers, these questions and answers are all different in them. Now, anyone that's thinking, wait a minute, why has he said 8 planets there? That's because Pluto is not a planet, officially. And the smallest planet, again, not Pluto, it's Mercury. I was surprised. When I was putting this course together, I put this in as 9, and then I had to Google it. So if you thought, why there are not 9 planets there, you're not the only one. So what we can do here is we can loop over these questions and answers using a for loop to kind of ask the question to the user and then check it against the answer. Okay, so as good practice, first thing that we want to do is I'm going to scroll down here. First thing that we want to do is let's make a function that will actually conduct our quiz for us. So here I'm going to make another comment just to say what it's going to do. So what we want to do is we want to loop over our Q and A, ask the user the question, check their answer, and then move to next question. Okay. Hopefully that will become apparent. Ooh, looks like I've got a little error here. Line too long. You know what? Fine, we'll deal with that. Okay, so how do we define a function again? Yeah, shout at your screens. Yeah, there we go. We use def. We define our function using def. So I'm going to call this conduct underscore quiz. What do we need as part of this? We need some parentheses. And then afterwards, we need to add a colon and 2 dots. Now, we need to have an indentation to say that the code that we're writing is inside this function. The great thing about Replit and any text editor, for that matter, that's any good anyway, if we just hit enter here, you'll see that we're actually indented already. Now, we could, if we found that we were here by accident, we could just hit tab to get us back to the right indentation. But once we've written we've done def, then the function name, then the colon, if we hit enter, Replit will indent for us. And that's really good because it means that we can use the software to make sure that we're always writing the code the way that we expect. Okay, so here, let's just test. Let's just say print, and we're using parentheses here, which tells us what? Anyone clever? Yeah, print is also a function. So we're going to say print out to the console something. And in the parentheses, we're going to put some quotation marks. And we'll say, welcome to the quiz. Excellent. So we've got our function, and what we should have is printed out to the console, welcome to the quiz. Okay, let's go up here to the big green button that says run and run our code. Okay, that was disappointing. Nothing happened. Anyone wonder why? Anyone know why? Well, we've written our function, but it has not, we've not called upon it. So what we need to do is we need to say conduct underscore quiz here and add parentheses. You'll notice that I only open the parentheses and Replit closes it for me. Another handy little thing that it will do for us. Okay, now let's hit run. Welcome to the quiz. Fantastic. Our function is running. We know that that runs. Now, when we put any code in here, we know it will run. It might not do what we want it to, but it will run. Okay, so first thing that we want to do is we want to get our questions into our function. So if you think back, the way that we do that is in here, we can add a parameter. So I'm going to call this questions. And then this should send our questions into our function. Okay, let's run that code now. Okay, Python's given us an error. It's saying, hey, something's wrong. You need to go and fix it. So it's saying our conduct quiz is missing one required positional argument. Questions. Ah, okay. So we forgot to put something in here. We forgot to put our questions in here. So what we want to do is we want to put this variable, all of this, into our function. So let's go ahead and do that. So I'm going to say, when you call upon the conduct quiz function, go and grab our quiz questions variable here. So inside this set of parentheses here, we're going to say quiz underscore questions. And you see again that Replit is helping me out, saying, hey, I think you mean this one. Right, let's have, look, brilliant. Our code now runs because we're sending in that data into our conduct quiz function. We do need to do something with it, though. That's what we'll look at next. So what we want to do is we want to loop over our questions and answers. We want to write our program that goes through each of our questions and answers. So the way that we do that is we can do it with a for loop. So we can say for, and we'll say question underscore dict. So for every question dict, for every one of these, in our questions, because we're passing in our quiz questions, remember, in questions, we want to do something. Okay, so I'm going to hit colon there because this is another code block. Hit enter, and you'll notice that we're indented again. That's because we're now writing code that will happen every time this for loop runs. So all I'm going to do here for now is I'm going to say print And what I want to do is, I want to go ahead and just print out this question dict here. So I want to say print question dict. Okay, so if I run this now, you'll see that what's happening is we're passing in all of our quiz questions into this function here, and we're looping over it. We're looping over that data that we've passed in this for loop, and we're printing out every single item in that list. And we can see here, brilliant, we've got question, how many planets are there? Answer is 8. Name the largest planet, Jupiter, etc., etc. Now, we probably want to do something a little more interesting with that, though. What we want to do is let's kind of do some good coding. Let's get our question and let's get our correct answer. So our correct answer is this here on each dictionary. So I'm going to say question, and we're going to save this as we're going to save our question in this question variable. And we're going to go into this question dict, like we see here, and we're just going to get this question here, the value of this key here. So how do we do that? What we do is we go and say, go into the variable, go into that one dictionary, we say question dict, and then we use square brackets. Now, this might look a little bit odd, but it's just the way that Python works. And we give it a string, again, using the single quotations, of whichever key we want it to contain. So now I'm going to say, go and get the question key. The word question lost all meaning to anyone yet? I know it has to me. Okay, so just to test here, now let's say print, open some brackets, our question. Now let's run. Fantastic. Now, we don't just get the whole dictionary, including the question and the answer. We just get this string here. Well, that's a little bit more user-friendly. Excellent. Let's now get rid of this because we don't need it anymore. We just did that to test that we were getting every question. So under here, let's also get our correct answer. Now, if you think you know how to do this, go ahead and type out what you think the answer is, or what you think we need to do here. Again, we're accessing that question dict, and we're trying to get the key answer. So if you want a clue, have a look at line 25. So we'll say here, go ahead and go into the question dict, square brackets, to get our answer key. Let's just do a bit of a test. Print correct underscore answer. Run our code. Yay, fantastic. Now we get all of our correct answers. We've got those bits of data, those strings, from our main list. Fantastic. So there's one more thing that there's a couple of things that we need to do, but something that we need to do here is we need to get some user input from our user. So instead of just printing out correct answer here, what I'm going to do is we'll say, ask the user to input something into the console and save that into a variable. The way that we do that is, well, it's just like any other variable. So we will say user underscore answer. So this is whatever the user has told us they want to answer for that question. We'll set that equal to. We'll use another function that's included in Python for us called the input function. Now, this input function is actually very handy. In here, we can add what's called a prompt. And that will kind of print out to the console something, a string of letters or words, and then we'll allow the user to input some other data, another string. So here, what I want to kind of give the user is this, it's the question. We want to ask them the question. So in here, we can say, go ahead, and whatever is in this variable here, this question variable, prompt the user with that text. So in here, I'm going to write question. Okay, so let's hit run. Welcome to the quiz. Okay, how many planets are there? Brilliant. We've come all the way down here, and we've come to this input, and it's actually asked us with the prompt, how many planets are there? Brilliant. The first question in this list. Fantastic. So if I put in 8 there, name the largest planet, I'm just going to put 8 again. Okay. So it's not really doing anything. We haven't coded that yet. That's fine. We're going through every question, asking the user to put in an answer. Fantastic. This is getting closer and closer and closer to actually being a functional quiz. Okay, I'm just going to stop my code there. So what we need to do here is we need to kind of, inside this for loop, so just make sure that you're at the right indentation. I've left a line here, so just make sure that our cursor is at the same level as we were before. So I need to be one more in so that I'm inside this for loop here. So what we want to do is we want to kind of compare our user answer to our correct answer and decide whether that's correct or not. Okay, so we can do that with an if statement, a conditional statement. We can say here, if our user underscore answer is equal, so remember that double equals, if they are the same as the correct answer, we're going to add a colon and do something inside this code block. Notice that we're indented again because we're now inside this if block. So what I just want to do is I want to print, hurrah, that is correct. Because if the user inputs the same thing as our correct answer, we know that it was correct. Fantastic. What if they got it wrong then? Well, what we need to do is we need to unindent ourselves so that now we are on the same level as our if. And we need to say else. So if the answer is the same, print, hurrah, that's correct. If it's not the same or else, do something else. So what we'll do here is we'll say colon. Notice that we're now indented into our else block. We are now going to print wrong. the correct answer is, and what I'm going to do here, I'm going to add a colon, just so that it reads nicely. After this quotation mark here, I'm going to add a comma. And then I'm going to say, go ahead and print wrong, the correct answer is, and then this correct answer. So I'm going to say correct underscore answer. And you see that Replit has gone and put that on a different line for me. I'll just move this about, hopefully, to make it a bit easier to read. Okay, so let's have a look at what happens here. Okay, so if I hit run, and we say, how many planets are there? I'm going to say 8, and then hit enter. Hurrah, that is correct. Fantastic. Name the largest planet. I'm going to say Venus, and hit enter. Ah, wrong. The correct answer is Jupiter, because we've gone ahead and we've printed wrong, the correct answer is, and then gone and got the correct answer out of this variable here, which is on our question. Hey, that's pretty good. That, I think, really is a very basic, very basic quiz. We can get to the end. You know, what's the smallest planet? Mercury. Yeah, fantastic. That's correct. Coldest planet is I can't even think. Uranus, I think, isn't it? Correct. Hottest planet. Let's say wrong. Correct answer is Venus. Brilliant. We can get correct and incorrect answers. Wrong. The problem is, though, that's a little bit unsatisfying. I think we can improve this application in a couple of ways. So the first one is, I think we should probably keep score. We should probably keep score of how many correct answers there are. So what I'm going to do here is right at the top of our conduct quiz function is I'm going to make a variable called score. And then we're going to set this equal to, or we're going to initialize this as 0, because when somebody starts our quiz, they have 0 points. Then what we can do is we can add 1 to this score every time they get a question correct. Well, we can do that inside this if block here. So just after we've printed hurrah, that is correct, just underneath, and remember, we need to be inside this if block, so it's indented to the same level as this print. We'll say that score, we use the equals to now reassign this variable. And what do we want to set it to? Well, we want to set it to whatever score is at the moment plus 1. So they add 1 more point. So we'll say that score is score plus 1. Now, there are different ways of writing this using different operators like this plus equals, etc. But I think this reads quite nicely. We're saying, hey, go ahead and reassign this variable, this score variable, to whatever it was plus 1. I think that reads quite nicely. Let's go ahead and once we've finished this whole thing, let's go and tell our users how many questions they got right. So what I'm going to do is, you see this else block, I'm going to underneath it. So I'm currently inside this else block here. But if I press backspace, you'll see that I'm now inside this for loop because we're now indented in there. If I press backspace again, you'll see that we're now just indented 1 level from this function. This means that we're just writing code that will happen after this for loop has completed. So be very careful with your indentations. This is the one thing that beginners and experienced developers get really unstuck with in Python. So what I'm going to do is I'm going to say here, print, and then we need some parentheses and some quotation marks. So we're going to say print, you scored. And then again, we need to go ahead and get that score variable. So outside of that quotation mark, I'm going to add a comma and then say score. So print out the words you scored, and then afterwards print out whatever this variable is. So let's go ahead and test that now. I'm going to go ahead and hit run. So we'll say, how many planets are there? There are 8. Well, that's correct. The largest planet is Jupiter. Smallest planet is Mercury. Oh, that's a bit weird, isn't it? Anyone probably saw this coming. But we'll come to this anyway. We'll come to this later. What's the coldest planet? I'm just going to type some nonsense so that we get to the end of it. Excellent. So you scored 2, which means that every time we've got a correct answer, every time that this is true, the score is updating. We get 1 added to the score, and it's printed out there. Okay, so we've just run into a little problem here, if anyone can see what it is. So here I was asked the question, name the smallest planet, and I entered the word Mercury. But I got wrong. The correct answer is Mercury. Now, to us humans, if we were doing this as a quiz, talking to each other, it would not matter. But our computer sees these 2 things, the Mercury with a capital M or an uppercase M, as completely and entirely different to the Mercury with a lowercase m. So we need to sort this out. So there's a couple of ways that we can do this. But what I'm going to do is I'm going to say, if the user underscore answer, if this dot lower, and we need to add some parentheses afterwards, because this is what's called a method, and it lives on our string. It's all hidden away in Python for us. But what it will go ahead and do is it will make this user answer lowercase. All of it will now be lowercase. So if we were to type lots of uppercase letters in our user answer, it will just put them all to lowercase. If they're all lowercase anyway, doesn't matter. It will just keep them all as lowercase. So this is kind of part of a subject of input validation, or not validation, input validation. And it just makes sure that the data that we expect at our software, it doesn't matter if the user makes some small mistakes, or if they input something that we don't expect, we can deal with that issue in our program. Cool, so let's give it another little test. How many planets are there? There are 8. Excellent. Name the largest planet. I'm going to say Jupiter with loads of uppercase lettering. Hooray, that is correct. Because I got the right answer, I just put the wrong capitals in. Doesn't matter. Name the smallest planet. Mercury. Yep. Coldest planet is Uranus. Let me spell it right. That's correct. And the hottest planet, let's say Uranus again. And that is wrong. You scored 4. Fantastic. I think that's done. We've solved the problem where we want the user wants to test their knowledge of the planet because they are asked questions and their answers are all checked. Fantastic. Let's go ahead and submit this to the client. Let's see if they're happy with it. Okay, feel free to have a play around with your newfound, your new software. Okay, give me 1 second just to get everything back as it was. Let's play this again. Yeah, absolutely. So the Schools IT teacher provided the questions and answers, and we were able to use those, and the student was able to test their knowledge of the planets and the solar system. Think we did that? Excellent work. The client is extremely pleased with the software. Now, that might sound like a little bit of an arbitrary example. It might be a bit funny, but kind of trust me when I say this. Every piece of software that's written in Python, and arguably every other language, is made up of those fundamental building blocks right there. There's just more of them, and they just do slightly different things, you know, depending on what the software is required to do. So yeah, everyone go ahead, go get your CVs, update it, say Python developer, and there we go, off to get a new job as a Python developer. Okay, maybe there's a bit more to it than that, but what you do have is the kind of the fundamental building blocks of Python development. I think everyone deserves a round of applause there. Well done. Okay, so if you enjoyed that, what next? Well, keep learning, basically. I would say keep doing this. Keep writing small little things. See what you can do to break your code. You know, can you add some more features? Can you add another for loop somewhere that goes through multiple answers? It's entirely up to you. So obviously I am from Flatpak Coders, and you know, we provide engineering training and focusing on career changes and people that want to create their own tech. I would love to see some of the names that I can see in the participants list here signing up to our next cohort. If you would like some more information, please go ahead and have a look at our website. If you've got your phone in your hand, that QR code will take you to our website, flatpakcoders.com. And the great thing about our code, this was a very small, tiny portion of the software engineering course, but it kind of hopefully gives you a little taste. Our courses focus completely on a learn by doing. We have a complete learn by doing ethos.